Hello guys, I am Vaibhav Lokhande and we are going to discuss about binomial distribution in this video lecture. The result of an experiment with two possible outcomes is called a Bernoulli's trial. For example, when we flip a coin, there are only two possible results, either head or tail. It is named after Jacob Bernoulli, who made important contributions to probability theory. In general, a possible outcome of a Bernoulli's trial is called a success or a failure. Binomial distribution was first studied in connection with games of pure chance. A game of chance is a game whose outcome is strongly influenced by some randomizing device and upon which contestant may choose to wager money or anything of monetary value. Common devices used includes dice, spinning tops, playing cards, roulette wheels or number balls drawn from a container. Any game of chance that involves anything of monetary value is gambling. Binomial distribution was introduced by Jacob Bernoulli, who addressed it in his work The Art of Conjecturing. The Art of Conjecturing is a book on combinatorics and mathematical probability written by Jacob Bernoulli and published in 1713, 8 years after his death by his nephew Nicholas Bernoulli. The various contents that we are going to see in this lecture are preliminaries, important criteria of binomial distribution, deriving a formula, questions, useful links, and some references. In preliminaries, we will discuss some basic terminologies in probability theory that we must know to understand binomial distribution properly. An event is a set of outcomes of an experiment to which probability is assigned. In independent event, probability of occurrence of one event doesn't affect the probability of occurrence of another event. Any experiment whose outcome is unexpected is a random experiment. Random variable represent all the possible values from a random experiment. For example, tossing a coin, there are two possible results, head and tail. Let's give them values, h equal to 0 and t equal to 1. And we have random variable x, which is having two values, 0 and 1. Discrete random variable can have finite or countably infinite number of values. A probability of any event A can be defined as number of ways event A can occur divided by total number of possible outcomes. The important criteria of binomial distribution are all the trials in binomial distribution are independent. There are two possible outcomes of each trial, either success or a failure. The probability of success at each trial is constant. Now we will see some examples and derive the formula for finding probability with respect to binomial distribution. So consider an example. A fair coin is tossed 3 times. What is the chance of getting exactly 2 heads? As we can see in the figure, there are 8 possible outcomes of tossing coin 3 times. We require outcome which is having exactly 2 heads. These outcomes are highlighted in figure and there are 3 such outcomes. This is same as selecting 2 objects out of 3 objects. Thus we can use combination without repetition to find number of outcomes we want. As we can see, combination of 3, 2 is 3. In general, number of outcomes required can be given by C of n, k, which is equal to n factorial upon k factorial into n minus k factorial, where n is number of outcomes required and k is choices we want. Thus, chances of getting exactly 2 heads in 3 tosses is 3 by 8. Now consider second example. A bias coin is tossed 3 times with probability of head is 0.7. What is the chances of getting exactly 2 heads? As we have seen in previous example, there are 3 ways in which we can get exactly 2 heads. These 2 head cases are highlighted here. As probability of head and tail is different, we have to calculate probability of 2 head cases. We can use tree diagram for finding probability of 2 head cases. As each trial here is independent, we have to multiply probability of each trial. So in total we are getting 0.147. Can we get 0.147 from a formula? What we want is two 0.7s and one 0.3. Here 0.7 is the probability of each choice we want, as probability of head is 0.7, and we want two heads in 3 trials. So 2 is the number of choices we want. Let it denote by k. So the probability of choices we want is p raised to the power k, and probability of choices we don't want is 1 minus p raised to the power n minus k. So all choices together are p raised to the power k into 1 minus p raised to the power n minus k. So probability of exactly 2 heads in 3 tosses is given by 3 into 0.147, where 3 is all the possible choices for exactly 2 heads and 0.147 is probability of each 2 head case. So in total the probability will be 0.441. Now we can get the formula for binomial distribution, which can be given by outcomes required into probability of each outcomes. So it equals to combination of n comma k into p raised to the power k into 1 minus p raised to the power n minus k. This is one exercise question for you. I suggest you to pause the video and try to solve this question and verify your answer. So guys, our question is, a fair coin is tossed 6 times and we have to use the binomial probability formula to calculate the probability of at most 2 tails. Here we will use random variable x that represent all the possible of our experiment. So all the possible values of x will be 0, 1, 2 up to 6, because at most we can have 6 tails in 6 trials, and we have been asked to find the probability of at most 2 tails. So we have to find probability of x less than or equal to 2. So it can be written as probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. Here, as value of x is 0, we will write our binomial distribution formula. We have to select 0 tails from 6, and probability of each head and tail is 0.5. Now we have to select one tail from 6, probability is constant, and now there is one tail, so we will have 1 in the power. Similarly, we will write for probability of x equal to 2. When you perform this calculation, you will get the result 11 by 32, which is the probability of at most 2 tails. I hope you understand this example. If you want to study probability and binomial distribution in further details, you can always refer this link. First one is a book, An Introduction to Probability Theory and its Application by William Feller, and second one is online course, Introduction to Probability and Statistics on MIT OpenCourseware. The various references that I have used to prepare this lecture are: first one is online course, Introduction to Probability and Statistics on MIT OpenCourseware. Second one is a book, District Mathematics and its Application by Kenneth Rosen, and I have used Britannica.com for referring history of binomial distribution. I hope you have enjoyed this lecture. Thank you.